In our lesson today, we're going to introduce solving and graphing inequalities. Okay, our past few lessons have been all about solving equations, and now we're going to take a look at how we can solve and then graph inequalities. An equation is a mathematical sentence that states that two expressions are equal to each other. Okay, an equation always has an equal sign. An inequality, however, is a mathematical sentence that states that one expression is either greater than, which uses that symbol, okay, or less than, which uses that symbol, another expression. An inequality is a sentence that states that one expression is either greater than or less than another expression. Now, when we talk about inequalities and their symbols, there are two phrases that we're going to need to remember. Preserves the inequality symbol means that the symbol is unchanged. Okay, when you preserve something, you keep it the same. The symbol will be unchanged. All right, but when we say reverses the inequality symbol, that means that the symbol changes to the opposite symbol. Okay, so if it was greater than, it would switch to less than, and vice versa. Reverses the inequality symbol, the symbol will change to the opposite symbol. In our first exercise, we're going to learn how we can graph inequalities. Okay, earlier in the year, we graphed integers by plotting a point on the number line where the integer was located. In example number 1, we want to graph the integers that are greater than or equal to -3. This symbol right here means greater than, or equal. Okay, if it's got that little line underneath of the greater than symbol, that means greater than or equal to. We want to graph all of the integers that are greater than or equal to -3. Okay, and since we're allowed to be equal to -3, we would start at -3 by placing a dot where that's located. Then we're going to graph all of the integers that are greater than -3. So the integers greater would be -2, -1, 0, 1, 2, 3, 4, 5, and so on. Now, to show that this would continue, this arrow right here at the end, we're going to make it big and bold to indicate that the rest of the integers to the right of 5 are also greater than or equal to -3. So that would include 6, 7, 8, etc. In example number 2, we want to graph all of the integers that are just greater than -3. Okay, notice there's no line underneath the symbol this time, so we want only the integers that are greater than -3. Since I can't be equal to -3, now I'm going to have to start at -2. So I'll plot a dot at -2, and then -1, 0, 1, 2, 3, 4, 5, and so on. Bold that arrow to the right-hand side. Okay, those are all of the integers that are strictly greater than -3. Okay, but we're not only going to be working with integers, we're also going to be working with fractions and decimals. Okay, so we're going to have to include all of the numbers which we call real numbers. Okay, we're going to graph the real numbers, which include the integers as well as fractions and decimals. Okay, so if we were just graphing integers, we would put a dot on each integer. But now since we're graphing integers, fractions, and decimals, our graph is going to look a little different. Example 3, graph the real numbers that are greater than or equal to -3. Well, again, since I'm allowed to be equal to -3, I'm going to put a little dot on -3. But now I need to make sure that I get every single fraction, decimal, and integer that is bigger than -3. So what I'm going to do is actually bold the entire line to the right of -3. This will allow me to make sure that I include every single fraction, decimal, and integer that is greater. And then again, I'm going to make my arrow at the end big and bold. This is how you graph every real number. You're going to bold the entire line. In example 4, it says to graph the real numbers that are only greater than -3. Okay, since I'm not allowed to be equal to -3, I can't include it as part of my solution. And I can't start at -2 because there are a lot of fractions and decimals in between -3 and -2 that I wouldn't be including. So what we're going to do, instead of putting a dot on -3, I'm just going to put a circle that's not filled in. This means that I'm not including -3 as part of my answer. But now what I'm going to do, again, is bold the entire line to the right of -3, because again, this is going to let me get every single fraction, decimal, and integer that is greater than -3, and then bold the arrow at the end. Okay, so pay attention to your inequality. If it's going to have, if it's got an equal to part of it, you're going to shade that circle in like we did right here in example number 3. But if it, like in example number 4, it's just the greater than symbol or just the less than symbol, then you're just going to have a circle where it's not bolded in. In example number 5, graph the real numbers that are in between -3 and +2, and pay attention to the symbols, okay? We see right here that there's an equal to part underneath of the symbol, so we can be equal to the -3, but right here, notice we cannot be equal to the +2. So I'm gonna have to put a closed circle, I call it, on -3. Since I'm allowed to be equal to -3, I'm gonna put a circle and fill it in. But since I can't be equal to +2, I'm just gonna put a circle, an open circle. I'm not gonna fill it in. And now the variable is in between the two numbers, so I'm gonna shade the number line in between both of my circles. These are all of the real numbers that are between -3 and +2, including -3. Now that we've talked about graphing inequalities, let's talk about the rules for graphing our real numbers. If the inequality symbol is only less than or greater than, you are going to use an open circle, which again looks just something like that. You're not going to fill the circle in because you can't be equal to the number that they're talking about. But if the inequality symbol says less than or equal to or greater than or equal to, you're going to use what is called a closed circle on your number. So you're going to have your circle, and then you're just going to bold it in, shade it in. Okay, so use an open circle if it's less than or greater than. Use a closed circle if it's less than or equal to or greater than or equal to. In the next part of the lesson, we're going to investigate what adding and subtracting will do to our inequality symbol. We have a table here, okay, and what I'm going to do, I'm going to be rolling dice in order to come up with my inequalities. I've already done the first example for you, so I want to talk about how we did this. So I rolled the die, and I came up with a number that's -3, and then I rolled my second die, and I came up with my number of 5. -3 is less than 5, so my inequality symbol right now is a less than symbol. The first thing I'm going to do with this example is add 2 to both sides. That's what it says in the operation column. So I have to figure out what my new inequality is going to say. So let's show that we're going to add 2. I'm going to do -3 plus 2, and I need to see if that's less than 5 plus 2. Well, if I have -3 plus 2, I know that's -1. And if I have 5 plus 2, I know that's 7. And -1 is less than 7. So now I need to fill in the last column of my table. Was the inequality symbol preserved or reversed? Well, originally it was a less than symbol. It's still a less than symbol. So we're going to say here that the symbol was preserved. Remember, preserved means that we kept it the same. So adding 2 to both sides of the inequality preserved the inequality symbol. So we're going to continue on with our table, and what I did, I rolled my dice, I should say, in order to come up with the rest of the numbers that I'm going to use for each example. So let's take a look at our next problem where I rolled a 2 and a -4. My inequality symbol is going to start by saying greater than, since 2 is greater than -4. What they want me to do next to both of the numbers is add -3. So I'm going to do 2 plus -3. I need to see if that's still greater than when I do -4 plus -3. If I add 2 with -3, that gives me -1. And if I add -4 with -3, that gives me -7. -1 is greater than -7. It's further to the right on the number line. So again, my symbol was greater than, it's still greater than, so I preserved the symbol. Adding -3 to both sides preserved the inequality symbol. When I rolled a 6 and a -1, my symbol also is going to be greater than. 6 is greater than -1. And now they want me to subtract 2 from each number. So I'm going to do 6 minus 2. Is that still greater than -1 minus 2? Well, 6 minus 2 I know is 4. With -1 minus 2, those are same signs. So I have a -1 and a -2, which is a -3. 4 is greater than -3. So once again, it looks like my symbol was preserved. In each case, my inequality symbol said greater than. What if we subtract -1? In the next example where I rolled a -5 and a +2, my symbol is a less than. -5 is less than +2. Let's subtract -1 from each of the numbers. I'm going to have -5 minus -1. All right, is that less than when I do 2 minus -1? Now, these are double signs. Okay, remember, subtracting a negative is the same as adding a positive. So this is really the same as -5 plus 1. Is that less than 2 plus 1? Well, -5 plus 1 is -4, and 2 plus 1 is 3. So yeah, -4 is less than 3. So my symbol in each case has said less than. So once again, I have preserved the inequality symbol. Subtracting -1 preserved the symbol. What if I add 1? All right, I rolled a -3 and a -2. -3 is less than -2. What's going to happen to the symbol if I add 1 to each of the numbers? So I'm going to have -3 plus 1. Then I'm going to have -2 plus 1. Is that still going to be less than? Well, -3 plus 1 is -2, and -2 plus 1 is -1. -2 is less than -1. So again, once again, I see that my symbol was preserved. Okay, adding 1 to both sides preserved the inequality symbol. So let's make a conclusion about our experiment. If we examine our results, what can we say about what just happened? We added and subtracted in our table, and every single time when we did that, the symbol was preserved. When a number is added or subtracted to both numbers being compared, the symbol is preserved. Okay, therefore, the inequality symbol is unchanged. That's what it means to be preserved. The inequality symbol will be unchanged anytime you add or subtract with an inequality. In exercise number 3, we're going to put everything together. We're going to actually solve inequalities. The process to solve equations and inequalities is the same. First, you're going to make a zero pair with the constant term, and then you're going to isolate the variable term by making 1. You're going to find the value of just one variable. Follow the golden rule. Do to one side exactly what you did to the other side. So in example 7, it says solve x plus 2 is less than 7, and then graph the solution on the number line. When you solve an inequality, instead of checking it, you're going to graph what the solution looks like. So we have x plus 2 is less than 7. The variable's on the left, but it's not alone. It's got a positive 2 there. Therefore, we're going to have to subtract 2 to get the x all by itself. And then I'll do the same thing on the right-hand side. On the left, when I do 2 minus 2, I get 0, leaving us only with x. And then when I do 7 minus 2, I get a value of 5. And now I need to remember what subtracting does to the symbol. In the last example, every time we subtracted, the symbol was preserved, so it's going to stay less than. X is less than 5. This is the solved inequality. The variable's alone, okay, and I can see that it's less than 5. Therefore, what I'm going to do is go on my number line, and I'm going to graph what this would look like. My starting point is going to be at 5. However, I can't be equal to 5. Since it's just a less than symbol, I'm going to put an open circle on 5. Now I need to graph every single number that is less than the 5. So I'm going to bold the entire line going to the left of 5. These are all of the numbers, fractions, decimals, integers, that are less than the number 5. And I'm going to bold this arrow on the left-hand side of my number line as well. This graph means that any number that is less than 5 makes the statement true. I can pick any of these numbers here that I've shaded in and use that for the value of x. For example, if I use the number -3, -3 plus 2, -3 plus 2 is less than 7 because -3 plus 2 is -1, and that is less than 7. If you picked a number that wasn't bolded in, say for example the number 8, the inequality isn't going to be true. 8 plus 2 is less than 7. 10 is less than 7. No, that is not true. That's why 8 is not shaded in. Okay, so any of the numbers that are shaded in would make a true statement for our inequality. X is less than 5. In example 8, we're going to solve each inequality and then graph the solution on the number line. So in letter A, it says m plus 8 is less than or equal to 2. The variable is on the left, but it's not alone. It's got that positive 8 there. So we're going to have to subtract 8 from both sides. On the left, 8 minus 8 is 0, leaving us with m. 2 minus 8 on the right is -6. And subtracting will preserve the inequality symbol. So this is going to say that m is less than or equal to -6. So I'm going to find -6 on my number line, okay? And since I'm allowed to be equal to -6, I'm going to use a closed circle. And now I need all of the numbers that are less than -6, so I'm going to be bolding the number line to the left and bolding the arrow on the left as well. This is what the solution for m is less than or equal to -6 would look like. Take a look at letter B. -7 is greater than or equal to m minus 13. Notice in this case that the variable is on the right-hand side. With an equation, it doesn't matter which side the variable is on, but with an inequality, it does. We always want our variable to be on the on the left-hand side. So let's make a note of that. The variable needs to be on the left. Okay? If you have an example like this one where the variable is on the right, we're just going to change the inequality. I'm going to move m minus 13 to the left-hand side. I'm going to move -7 to the right-hand side. And since I switched the order here, I'm going to switch around my inequality symbol. Instead of saying greater than or equal to, I'm going to make it say less than or equal to. m minus 13 is less than or equal to -7. Now the variable is on the left, but it's not alone. It's got that -13. So I'm going to have to add 13 on the left, which means I'll add 13 on the right. On the left-hand side, -13 plus 13 is 0, leaving us with m. And on the right, -7 plus 13 is equal to 6. And adding, again, will always preserve the inequality symbol. So m is less than or equal to 6. So now I'm going to start at 6, and since I can be equal to 6, I'm going to put a closed circle on 6. And now I need all of the numbers that are going to be less than 6. So again, I'm going to shade to the left on my number line. This is every fraction, decimal, and integer that is less than 6. Don't forget to bold the arrow on the left-hand side as well. Okay, taking a look at our last example, we have -3 plus j is greater than 4. Our variable is on the left where we want it, but it's not alone. It's got that -3 with it. So to isolate the variable term, we're going to have to add 3 to both sides. On the left, -3 plus 3 is 0, leaving us with j. And 4 plus 3 on the right is 7. And adding, once again, will always preserve the symbol. So j is greater than 7. All right, so I'm going to find 7. But since I can't be greater than 7, I'm going to have to use an open circle on 7. Since I can't be equal to 7, I should say, I'm going to use an open circle. And now every number that is greater than 7 would be to the right. So I'm going to shade the number line to the right. And then I'm going to bold the arrow on the right-hand side as well. This is the graph for j is greater than 7.